All right, so I'm going to do 3 topics right now. Mass versus weight. Then I'm going to talk about things that are intensive. And lastly, I'm going to talk about things that are extensive. So the first one's pretty easy to do. All right, mass versus weight. So there is a difference between the two, and it is this. So by definition, mass is the amount of matter present in an object. Okay? Now remember, matter is anything that has mass and takes up space, right? So it's the amount of matter. So, this pen that I'm holding has a certain amount of mass. I, as a human being, have a certain amount of mass. And so what happens with the amount of matter, for mass, is it's constant. It stays the same. So I could take this pen, take it to the moon, right? And it would still have the same amount of atoms, the same amount of molecules, etc., etc. And so, when you talk about mass, it's a consistent thing. However, weight is a little different. Because weight is dependent on the pull of gravity. Dependent on gravitational pull. And so what happens with this is, again, I'll give you an example. The moon, the gravity on the moon is 1/6 that of the Earth. 1/6. So, I weigh about 170 pounds, me, right? So, 170 pounds on the moon would be roughly, I don't know, I'm just kind of ballparking in my head, 32 pounds or so, approximately. 32 pounds on the moon would be my weight. But the amount of matter that makes up my body would not change because my mass would stay the same. So that's the difference between mass and weight. All right, now let's talk about this idea of intensive properties. So the big thing with intensive properties is they do not depend on the size of the object. I'm going to have to get a new marker here, but i.e., they do not, it doesn't matter what the mass is of the substance. So, things that are intensive. When I think about things, I think of things that, like, color is an intensive property, right? It doesn't matter how big or small it is, it's red. Other things you could think of as being intensive. Temperature, right? Give you a couple other terms. How about things like ductility, which is just a fancy word for saying being able to be drawn out into wires, like copper. Or how about, malleability, right? Malleability would be an example of one. Now, there is one that's kind of interesting, and that one is density. Now, when we study density, you're going to learn that density is equal to mass divided by volume, right? So you would think because there's mass in it, it would depend on the size of the object. But here's the thing. Density is also volume dependent. And so what happens here is this is very extensive, and we'll talk about that in a minute. But, density doesn't change if you have, a piece of steel or if you have, an entire boat that's made out of steel. All right? So, the object is significantly larger when it's the Titanic, right? But, and it's not a great example, but due to historical moments, but we'll say, for density, you have this big steel boat. Well, it still floats, right, when you extend its density over all of this volume. And you account for other things also. So density is considered to be intensive. Let's see if there's anything else that I can think of or that I want to make sure I get to you. Sometimes you'll refer to elasticity. How stretchable an object is. So elasticity is one that may come up from time to time. Concentration, specific volume, specific heat, specific energy, pressure. Those are all examples of things that are said to be intensive. All right, let's attack this last area, which is extensive. So with extensive things, they do depend on how much of it how much you have. So how much substance is present is what I'll say. So give you some examples, all right? You know, mass. You know, if you just looked at, you know, Shaquille O'Neal versus me, or, you know, pick any professional basketball player who's, you know, 7 feet and 300 pounds, right? Their mass is going to be dependent upon how many atoms that particular object has. So mass by itself is extensive. Or how about, you know, volume, right? It does depend on the amount. You know, if I took a pail of water and compared that to the amount of water that's in Lake Superior, well, you know, that would be extensive because it does depend on how much stuff is present. Give you a couple of other examples. How about length? You know, think about the pencil that you're writing with. Well, if you go and you sharpen it, you're going to make it less length, but you're also going to be removing atoms from it. So, all right, the length of an object, mass, volume, length. We're going to eventually talk about something called the number of moles of an object, and basically what that is it's the amount of atoms. It's 6.02 times 10 to the 23rd, which is a huge number, but we'll get to that because we're talking about atoms that are really, really tiny, right? But if we took a whole bunch of these tiny atoms and put them together, we could, you know, get an object that was bigger or smaller depending on what it is. Okay? You know, if you wanted a bar of gold, you know, the number of moles that you'd have to have would be significantly more than if you had, you know, a little charm around your neck. Okay? So mass, volume, length, and moles are probably the most common. You know, one other one that I would throw on here is a topic that we've already covered, but I would also say weight is something that is extensive. It depends on the amount of or how much substance is present. Some of you guys might be trying to, you know, bulk up for football season right now. Well, then your weight would depend on how much substance is there. So, mass versus weight, intensive,